Can I get a brave soul to do the first one for me? Go. Add one each time. So 5, 6, 7. There will be nice ones like this in this course that go up by something that's nice. That would be a linear pattern if you're worried about this from grade 9. So the equation for that would be of the form y equals mx plus b.
The next one.
Go ahead.
Multiply by negative.
Good. So this is a multiplying one. You get the numbers here, 162.
Yeah, and then negative 486, 1458, negative 4,300.
I think we only need 3. Did I say 4? Yeah, I did 4.
You said 4.
The last one is how much? 4 negative.
Negative 4,374.
Okay, those are big numbers. Now, remember you get to use your calculator in this class, right? So I'm not worried about multiplying big numbers here. All right, letter C is where we start to get a slight bit more complicated. Did anyone get C? Tristan, go ahead.
I said add one to these difference.
Okay, good. Yeah. Yeah. Yeah, if you take a look, if you couldn't get that one, you're adding by one more each time. This would be something that's a quadratic, okay? That's what this would be. Because your first difference is, right, they're going up by one more each time, but the second would be the same. So that'd be something that would be quadratic. That's good. All right, letter D. This is a little bit tricky here again. Anyone see this one? Liam, go.
You add the numbers.
Okay.
Or
so what's the next one going to be then?
The next one would be
Okay, so let's just explain what happened there. So what Liam realized when he looked at this is called the Fibonacci sequence, is what this is. Okay, so what happens was in order to get a number, you add the previous 2. So you'd say 1 plus 1 is 2, which it is. 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34, is that right?
Yeah.
21, 34 is 55, and then 89. And that's called add the 2 previous terms.
Isn't that
Yeah.
spirals?
Yeah, there's all
Like when
sorts
you do
of,
art, right?
yeah, there's art. There's all sorts of application of that. They even say things like a honeycomb, right? Like based on the size of it. Like you start off with small, and then that's the way that it grows.
Yeah.
There's all sorts of things. Pine cones. Ask Mr. Curry. Mr.
Math.
Curry. No, he's not walking the other end. If he was, he would give you lots of application.
One of those days.
What if Mr. Curry's watching this video today?
His name's in it now.
Okay. All right, E. Choose another one if there's at least 2 patterns or somewhere. What'd you get?
C4.
Okay, how'd you get that? What's that, sorry? Yeah, okay, so this is just squared. 1 squared is 1, 2 squared is 4. They don't get a different pattern for that? Because there is a separate pattern. Hey, Julian? Go up by odd numbers, good. So this is going to be plus 3, plus 5, plus 7, plus 9, plus 11, plus 13, plus 15. So again, that's, oops, 15. So again, that's the thing with the times table, there's going to be lots of different ways to get it.
Wait, what? Make it square?
So if you take out 1 squared is 1,
Yeah.
2 squared is 4, 3 squared is 9,
okay.
4 squared is 16. All right, so again, this is, again, x squared, the second difference would be the same. Anyone get the last one? Ever know what the last numbers are? This is such an old joke now, no one will even get it because it's really simple. Anyone watch Lost?
Yes.
4, 8, 15, 16, 23, 42. Usually Lost numbers. Okay. If you don't know what Lost is, that's fine. Lost is a TV show.
Lost.
But that was supposed to predict the end of the world. I don't know what it was supposed to predict lots of different things in the show. But the whole purpose was when that sequence came out of numbers, like mathematicians went crazy. Like they went insane. Like the producer just picked random numbers. It didn't even matter to them. But mathematicians went crazy trying to find the next number in the pattern. Like they use supercomputers. This is some people get into TV shows. You guys know this, right? Like
Yeah.
Mr. Kemp and Doctor Who. Like people go crazy about TV shows here. Okay, so. But anyway, they tried to find every supercomputer possible to find the next number, and there's no actual pattern, which is okay. Yes?
So for
So you can forget about F. F was a joke. A to E, you should know how to do those, right?
so like for any sequence, could you just like take a word formula if you want to call it that, and then make that?
Yeah, and that's what we're going to get into. We're going to make that. Yeah, we'll do that eventually. So Emma, is that a question or a stretch?
They're not.
You good? Okay. All right. So other than F, F's just me being mean. Okay. Okay. So we're okay on where the idea of the first five came from. Most people are.
Episodes, like an episode before the before.
I don't think so. I don't think so. I don't really remember where those came from actually. All right. So here we go. In math class, back to the notes. In math class. T1 equals the first term. T2 equals the second term. Multiply. If I were to ask you for T10, somebody tell me what T10 would mean, please. The 10th term, very good. Tn is going to be the nth term or the general term for the sequence. This is the how you can get any term in the sequence. Okay, and what we want is that's going to be an equation eventually. It's going to look like. Okay. We'll do a few of these to make sure it's good here. All right, but the idea is once you can get an equation for something, it makes your life a whole lot easier. And again, back to the football jokes again. People were counting on their fingers and toes for the pattern instead of using the equation. So I put on the first quiz, I said, find T1001. And one of the football players like literally did this, 3, 5, 7, 9, 11, 13, 15, 18, 20, and counted all the way up to 1001. They were wrong, of course. Okay, right? But, right, that was a mistake. They're fine individuals. And every year the football team says, yeah, Mr. Sadler, we did a calculation. The football team's actually smarter than everybody else. It's not true. But you know what? I'm going to pause this so I don't insult anybody. No, I didn't actually play. Okay, so here we go. Example 1 is going to say.
That was bearded example.
No, example 2. Find T1, T5, and T23. So A is going to say Tn equals 3n minus 1. So this is a lot like functions with half of x and all that fun stuff again. Okay. So once you find T1, T5, and T23, the first one I will do with you. Can somebody guess how I find T1 here?
Put it in for where the n is.
Very good. So I'm just going to replace n equals 1. So I'm going to write that as then T1 equals 3 times 1 minus 1 times equal to. So the idea is once you get the equation, this is really good. This is really easy. You can imagine the difficult part is actually making the equations. That's the difficult part. Okay, can someone else tell me please how I find T5? That's a 5, right? I'm such a bad printer. Somebody tell me what T5 is. Summer, go. Good. So T5, I'll do a different color. Equals 3 times 5 minus 1, which is going to be 14, I think. Oh, and how do I get T23? T23. Three times 23 minus 1, which is, what was that, 69 minus 1, 68. Can you confirm that for me? I think that's right. Are we all confirmed? We're good? Yes? Mine was B. Okay, I'm going to give you B and C and D, which will be slightly more difficult. You're still finding T1, T5, and T23. The equations are going to be worse. All right, are we good so far? Elena, are you good? Elena, I'm starting to be good. You're good too. Good. Why are you texting in my class?
That was
trying to work.
Let's skip jelly. That should be deadly.
Okay, B is going to be Tn equals 5n squared minus 3. Tn equals negative 4 to the n minus 1. And Tn equals n bracket n minus 1 all over 2 bracket n plus 2.
Is it 5n squared or is it 5 times n squared?
5 times n squared. So if it was 5n squared, like bracket 5n squared.
Okay.
Right, so 5 times n squared. Okay, do your best. I'm going to give you 3 minutes to do this. And, oops, sorry.
Yeah.